Hello everyone. So in the today's video lecture we will solve a problem on the MOSFET. So this is the first problem. So here consider the process technology for which L minimum is 0.4 micrometer. The oxide thickness is 8 nanometer. The mobility mu n is 450 centimeter square per volt second. The threshold voltage for the MOS device is 0.7 volt. So you need to find out what is oxide capacitance and process transconductance, okay, Kn dash. And for the MOSFET given, now for the different MOSFET you need to calculate what is the overdrive voltage VGS and VDS minimum for which the transistor is operated in a saturation region of 100 microamps. Okay, so we will solve first. So first to solve for COX and Kn dash. So the oxide capacitance COX is given by epsilon OX by TOX, oxide thickness. Okay, so here, so the epsilon OX is 3.45 into 10 power minus 11 uh, farad per meter square it is. Okay, and in the oxide thickness which has been given as 8 into 10 power minus 9 meter. Okay, so solving for this you will get around 4.32 into 10 power minus 3 farad per meter square. Okay, so this is the oxide capacitance. Since the care has to be taken that all the dimension has to be approximated to or taken to the same dimension of micrometer, we have to convert this into the micrometer. So for this what we have, COX is 4.32 into 10 power minus 3 farad per meter square, right? So now to convert it into micrometer, what we will do, we will multiply it by 10 power minus 6 and divide by 10 power minus 6. This is micrometer. Since you have micrometer square in the denominator, so we will add 10 power minus 6 again and 10 power minus 6 multiply and divide by 10 power minus 6 again. So totally what happens here, so it happens to be 10 power minus 6 plus 6 12, 12 plus 3 15, that means 4.32 into 10 power minus 15 farad per micrometer square. Okay, so this is written as 4.32 femtofarad per micrometer square. So this is how you convert the given into the constant, the required dimension, that is micrometer square, corresponding to the technology. Okay, so now this is oxide capacitance, and now the Kn dash, that is process transconductance. Process transconductance Kn dash is mu n into COX. So the given mu n is mobility of the electron, that is 450 centimeter square per volt second, into COX is this one, 4.32 femtofarad per meter square, micrometer square, sorry. Okay, so this is the process transconductance. So now this, to convert it to the micrometer square common dimension, what we will do here is mu n COX, that is 450 centimeter means into 10 power minus 2, meter square means 10 power minus 4 it is. So and we have multiplied by 4.32 into 10 power minus 15 farad per micrometer square, that is 10 power minus 12. Okay, so this is converting this, solving this, you will get around 194 into 10 power minus 6 farad per volt second. Okay, so this is equal to 194 microfarad per volt second. This is your process transconductance Kn dash. Okay, so this is how you convert the given parameters into the common dimension. Now the second part, which is for this you need to find out what is overdrive voltage and VGS. Since the current given is in saturation region, we have that ID is equal to Kn dash into W by L into VOV square, overdrive voltage square. So the ID is 100 micro is equal to Kn dash is 194 micro and W by L is 8 divided by 0.8 micrometer cancels, and VOV overdrive voltage square, overdrive voltage this one. So on solving for this you will get the value of VOV as 0.32 volt. So overdrive voltage is nothing but VDS. Okay, so in the characteristics, output characteristics, this is how the curve will be, VDS versus ID. So this is the point of overdrive voltage. Okay, so now this is the point here which is the minimum value for the minimum value of VDS, minimum value of VDS, which is equal to VGS minus VTH, to make the device to be in the saturation region. So VDS minimum itself will be 0.3 volt, 0.32 volts. So now to find out VGS, so this minimum value of VDS, which is equal to VGS minus VTH, so VGS will be equal to VDS plus VTH, which is 0.32 plus threshold voltage is 0.7. So VGS is 1.2 volt. So this is the value of VGS what we got here for this device. Okay, so now considering another problem here, that is the another problem what we consider here, we have a transistor, we need to design this circuit. Design the circuit means we need to find out what is the value of RD and RS. Okay, so this is the configuration what they have given, the RD, RS, and the RD you have been connected to plus 2.5 and source is connected to minus 2.5 and the gate is connected to ground. Okay, and for the current 0.4 milliamps, the drain voltage is given, the threshold voltage of the device is given, mu n cox is given, W by L is given. So the condition they have given is neglecting the channel length modulation. So for this we need to find out what is the value of this RD and RS. So now if we apply a simple Ohm's law across this resistance RD, so we will find out the current flowing through the RD, which is ID, given by, so 2.5 minus VD, this drain voltage, divided by that resistance RD. So VD given is 0.5, you can directly find out the value of RD, which is 2.5 minus 0.5 by ID, which is 0.4 milliamps. You get it as 5k, RD value to be 5 kilo ohm. Okay, so now for this, to find out the RS, we need to find out the similar method. For that we need to find out what is the source voltage. Okay, so now for this, assuming that the transistor is operating in the saturation region, so we consider ID is equal to mu n cox by 2 W by L VOV whole square. So ID is 0.4 milli, mu n cox is given, that is 100 micro by 2, W by L is 32, that micrometer and micrometer would cancels, so into VOV square. So we will find out what is the value of VOV. We get it as we get it on solving this, we'll get it as 0.5 volts. Okay, so using this, VO is nothing but VGS minus VTH is equal to 0.5 volts. You can find out VGS, which is 0.5 plus VTH is 0.7. So VGS is 1.2 volts. So VGS is 1.2 volts and Vg minus Vs is 1.2 volts. Since Vg is 0, so Vs will be minus 1.2 volts. So Vs is minus 1.2 volts. So similarly, you can find out the value of Rs as Vs minus this Vs minus 2.5 divided by Id. Vs is minus 1.2 minus of minus 2.5 divided by Id, which is 0.4 milliamps. On solving this Rd, you get it as around 3.25 kilo ohm. So this is how you determine the terminal voltage and design the circuit for the given value. Okay, so so in the previous problem I just made a mistake, I think. So this is 0.32 plus 0.7. So this will be VGS will be 0.7, 1.02. It is not 1.2, it is 1.02 volts. Okay, so this is the DC analysis or the problems on the MOSFET. Okay.